out on, like the CSSS site or something, something like that, because I enjoy a certain amount of reuse each year. Okay, function of a smoke test. What's the function of a smoke test?
Ensure the critical components of your application are not broken.
That's right. Yeah, very well put. So when a build occurs, when a commit occurs, when there's an update to the repo, there's a need to make sure it's a meaningful update, that it's a move forward rather than backwards, in that it shouldn't break the compilation of the existing code bases, right? If that contribution means other people can't even build the system to test with the new code on their own system, there's a big problem. That's one issue. And by and large, that's handled with the standard compile components of the build, right? It's going through and it's checking all the dependencies and all that sort of stuff that are statically determined. But beyond that, to make sure that it isn't a step backwards in terms of the whole project, you want to make sure that that commit to the repository isn't so disabling the basic functionality of the system that other people are not going to be able to do meaningful testing with the system, not going to be able to pursue meaningful work. I mean, if after that commit you can't even log into the system, for example, you really may be inconveniencing in a big way a lot of people associated with the project. And the smoke test is designed to allow you to make sure that those critical components of the system are still working after a commit, so that it's worth people essentially doing updates to get the new changes, the new results from the commit. So people have pushed it to the site, and the question is, should others be pulling it, right? If it so breaks the functionality of the system that it's basically unusable now, a system that was previously pretty operational is unusable, you don't want people to do pulls. You want to resolve those issues with the system. They may not have been caught in the compile phase, but they're being caught dynamically because the system isn't working. So it's a sanity check that the system isn't hosted when you run it. And we talked before, it can be composed of subtests. It doesn't have to be one monolithic smoke test that's custom written. It could be other tests that are basically putting the system through some standard paces, system-wide tests, say about login and a few common features, a few common use cases that you could use there. But overall, it's about making sure that one commit doesn't hose everyone's work and put everyone back by getting them to pull without it being ready for them to pull. Does that make sense? Okay, smoke test. And it's a big part of coordination in a larger team. Okay, 4 types of documents other than code in which peer reviews can fruitfully be conducted. What's something other than code you might review in a peer review session? Requirements doc. Good. Another thing?
Test matrix.
Test matrix. Excellent.
Design documents.
Design documents. Good. So sort of the architectural design or specifications of the interfaces for the classes which will be used. So Class A knows what, the person writing Class A knows what methods will be available in Class B and basically what they do. Okay? What other things? Test cases might be something you want to sort of do a peer review on. So what test cases are we forgetting about? Maybe all these are test cases which are sort of grouped, and we've forgotten about certain stress testing needs or certain needs as far as going and testing the system with error conditions, etc. Okay, so those are examples of some things other than code in which peer reviews can be conducted, and most things where you turn it into me, it could be conducted. For example, if you're doing coverage tests, or if you're doing a diagram of the different pathways through the system, so you can reason about how many of those pathways you've tested. How many of the transitions from screen A to screen B, for example. Those would be things you could conduct reviews on. So lots of things in which peer reviews can be fruitfully conducted other than code. Why is that important in terms of the value of peer reviews? Give me a reason why reviewing some of these things other than code might be particularly valuable.
Communication between the team members.
Yeah. So you think about, for example, a testing plan to communicate between the devs and the testers as to what's planned. Requirements, spreading the understanding requirements along. Yeah.
In terms of the code produced actually does what the client wants and actually is
Good.
fruitful.
That's right. So there may be tests which are in fact not in line with the requirements needs, for example, or a design plan which is not in line with the requirements needs. So those are good reasons. A lot of these early things, the requirements, the design document, architecture, those things have really disproportionate impact in terms of code. If something's really off in terms of them, there's a lot of work which has got to be redone often. Code rewritten, test cases may be redone. If it's requirements that are off, maybe you need to redo the design document, right, or parts of it. So these things have big ramifications. Another thing is it means peer reviews can begin early and can occur often. You can do them before code is written. You can do them while you're still planning out how things are going to coordinate together. That's pretty valuable, even if it's just in a short sprint of 2 to 3 weeks, like it's quite common in a lot of companies around town and a lot of companies in industry. So that's good. Discipline and maintaining a continuous integration process. How does that help? What are some of the benefits that come from continuous integration? Yeah.
The bugs are found relatively quickly and immediately know the source of the bug.
Those are two really good things, Nick. Two really good things. So you find the bugs sooner. You find the defects sooner. At the technical level, you find the failures which alert you to the defects sooner. And then you go in and you find the faults behind them. And fundamentally, you know where they're coming from sooner because there's been less change, right? Imagine if you wait, a month. You do a month's worth of work, all the different people in your team, before putting it all together. This is the strategy. It used to be called the Big Bang strategy. Okay, a Big Bang because people would be working for a while and then you put it together and it wouldn't work. There's a famous project at Microsoft called the Microsoft Omega. It was the predecessor of Access. You folks heard of Microsoft Access, database solution, sort of single user database most of the time. Anyway, it was famous because it was a very sophisticated project and the different parties as part of it, different software developers were working on different parts and then they put it all together. They put it all together to compile together and form a single unified project. And like the proverbial story of Charlie and Under the Streets of Boston, it never converged. So it just went on, I think it was 2 years or something. They were just trying to get the pieces that came together for it to work together nicely. And a certain amount of that was just compiler errors, actually, believe it or not. But then there were issues probably beyond that of sort of the pieces calling each other, et cetera. So if you go for a long time before checking things in, and you contribute things that have been worked on for a while, chances are that there'll be big incompatibilities between the different pieces. I made certain very reasonable assumptions, and I contributed this. You made certain very reasonable assumptions, you contributed that. But our assumptions are not compatible. Maybe I thought you were going to do something, you thought I was going to do that thing, and it's missing. Or, we duplicated something, or I thought it was to be done this way, you thought it was to be done that way. It was something that involves a coordination between our code, and each of our code is reasonable, but it's incompatible. These things can really happen. And the more often you're checking things together, the less likely you're going to be operating blind like this for a long time without realizing that there's an incompatibility in ideas. And if something goes wrong, like Nick was saying, if something goes wrong, there's fewer things changed. And so, often the system was working the last time we synced up. And if it's not working now, if it's only been 1 day of time, so only so many lines of code that have been changed, so many parts of the schema or whatever. But if it's been a month or 2 months, there's a lot of things that have changed between that. And if there's a bug, there's a failure occurring, where could it live? Well, let me count the different places. I mean, it's hundreds and hundreds of them. But if it's only 1 day, it's probably narrowed down to a small set of differences. Does that make sense? Continuous integration, ladies and gentlemen. Continuous integration. I tell you, practice continuous integration. Yes?
Are the smoke tests then like a component of continuous
Yes.
integration? It sounds similar.
Absolutely, yeah. So the smoke tests, great question. Thank you. Your name again?
Owen.
Owen. So smoke tests are a key component of ensuring that the commits, which occur as part of continuous integration, the commits and pushes in Git, that they are worth other people getting. Because the idea of continuous integration is, I should be, as a developer, going and updating my code base locally, like my code base on my machine, typically at least once a day, sometimes more than once a day, off the commits of others. And why should I be doing that? Because I want to know as soon as possible if my code is incompatible with theirs. I want to know it, right? And if something is wrong, if there's a defect, I want to be able to find it in as quickly as possible, in as a small delta as possible. So with this discipline of continuous integration, I am sort of refreshing my code base off of the changes of others frequently. And a key thing there is that because I'm so dependent on pulling others' changes, with pull requests being sent out and so on, that if they committed something which is going to cause major problems for me, they committed something which is going to mean I can't even make progress in my work because I can no longer test my part of the system because the system is so hosed that I can't even run anymore. That's going to be a big change. So the more people are dependent on getting each other's recent changes, in a way, the more important it is you make sure that those changes are meaningful for them to get. Because if they commit something which hoses the system, I don't want to get it. You probably don't want to get it until they fix it. Mind you, it may not be totally their fault. It may be they checked something in, it's just it wasn't ready to work with the latest versions of other people's components. Now they checked it in and the system's hosed. Yeah.
You could even say that it helps in the sense that if you're having like Docker images, and let's say that 2 people have merge requests at the same time,
Right.
they're both valid, they were both built properly, but without continuous integration, you have to like build the images manually. So if one person built their one image and the other
Right.
person built their one image, and then pushed it up to the Docker registry, you'd still be missing features from each of those images.
I think that's a really good point. Because, if they were manually building this thing, there might have been a check-in by someone else during that time or changes. And so my Docker image will miss your contributions, yours will miss mine, and it's sort of a race condition. Like we get ours there, but neither incorporates both our changes, right? So very good point. And you want, I like that point a lot. So with the continuous integration pipelines these days, for example, the GitLab pipelines, it supports creation of the Docker image as an element of the pipeline, rather than as a special case thing you brew up on your own machine and put up there. So you have a very quick turnaround, essentially, when you are putting something into place to what it incorporates. So I like that point, and much appreciated, Peggy. Okay, So, four processes other than compilation and linking that will often be included in a build. What besides compiling and then linking together, say, the different .class components or jar files or into a fat jar, or linking together different .o files into an executable? What other things besides that might be done as part of a build? Yeah.
Running a test suite.
Good. Running a set of tests. Could be unit tests, could be system tests, would certainly include, and this is actually conceptually a separate item, a smoke test, but it could also include regression tests, right? What's the difference between a regression test and just any old system test? What are we particularly concerned about with regression tests?
Making sure that.
Sorry? Race condition.
It's there to test a defect if it after it's been found.
Good.
To make sure that it's been fixed and it's not going to be.
That's right. And in fact, in industry, so that's good. You generally put in place regression tests to make sure that a defect hasn't reared its head again, which is typically, I think I could say, fairly an ugly head. Ladies and gentlemen, regression tests are very important because often defects do come back. They bounce back because of merge conflicts that lead people to resurrect earlier code, or because same faulty reasoning, same misunderstanding of the requirements. These things come back. So making sure that a bug stays fixed, that it doesn't wander zombie-like back to life and start terrorizing the team, is a desirable thing. Wouldn't you agree? Yeah. Okay. At least I don't hear strong disapproval. But ladies and gentlemen, regression tests are also used in a different sense in industry, in some quarters of industry, which is they're used to make sure the system hasn't regressed, in the sense of not only defects that were fixed before stay fixed, but the system functionality hasn't gone backwards in terms of features stopping to work. And if we get time for it, and I think we will at some point, I'll just share the notion that it's a lot worse for a user to have, it's bad. It's bad for a user who gets a new version of a product, new version of a service. They've heard that a new feature is included and it doesn't work so well. I think most of us have been in that sort of situation. We hear a new release of X will support this thing, and we say, cool, we'll go get that. And it turns out to be disappointing. It doesn't work nearly as well as we'd like, or it doesn't work for us. That's bad. We haven't gotten the value we sought in this new release. But what's much worse than that, I would argue, is where something you've used for months or years, you've counted on, you've built it into your workflow and your whole use of this product or service, that starts to fail. Now you've taken a step backwards. You've added negative value. You've not only not added value gained, you have taken away value from a person by having something they're counting on, that their life depends on, elements of this to do their daily job is now failed. And this is why in some quarters the term regression test is also used for that. It's to make sure this very important concept of making sure the system functionality that has worked before still works. Most commonly, you'll see it for regression tests, make sure the bugs don't reemerge. Okay, but both those are valid notions. Okay, so what else might be included in a build, though, besides these things? I mentioned a thing earlier. Peggy alluded to it.
Well, you can build Docker images and push them out to a registry.
Yeah.
You can also deploy your project.
Yeah, great. So you can engage in containerization, Docker, Rocket, what have you, and Docker being a particularly well-supported containerization strategy, and one that can link in with Kubernetes and larger frameworks. Alternatively, you can push out. You can push out to deploy. You can deploy to test servers, deploy to production servers, if you want to do so. And that deployment step is often really valuable to shave off time, get it out there for further testing. Another thing you might do is rebuild a database from scratch based on a schema, for example. Repopulate that database. Perform style checks. These are all things that might be incorporated in a build, okay? In a build and as part of a continuous integration system. And as computer systems have sped up, we generally put more things in there. Time was a big project. You wouldn't have time to run all your unit tests as part of your continuous integration suite. There were just too many, or your regression tests. There were just too many of them. You might have thousands of these tests, regression tests alone, and then comparable numbers of unit tests, and you just wouldn't have time traditionally. These days, what we're putting in our continuous integration is becoming more and more aggressive. When I wore a young man's shoes, we did have shoes in those days. We do daily builds. I was on the first team that was sort of famous for coming up with that innovation, and it was key. But it could only run daily because it was such a long process to build the system. It would take hours. And so you'd set it going at 10 p.m. at night, and it would be done by 6 a.m. in the morning. Function of risk scanning. What are you doing in risk scanning? What's going on in risk scanning?
Identifying things that aren't a problem now but could be soon.
Good. Identifying. I like how Eric said it. Identifying things that aren't problems yet but could be soon. Today's risk is tomorrow's problem if we don't attack it. And remember, was it Tom DeMarco or Jerry Weinberg that said, if you do not aggressively attack project risks will aggressively attack you. Okay, and history suggests it's true. There's two types of issues, though, that might fall under that general category. One is things that you identified before as risks. They just haven't, as we say, materialized. They haven't come about. Yet, and you're scanning for them based on your risk list. But another thing a risk officer should be doing, should put an emphasis on, is looking for new types of risk as well. They should be scanning, are there any new types of risk? And often new types of risks do emerge, even in the course of this semester, as you undertake new stages of the project. You incorporate new technologies. You make a different choice than you anticipated early on about how you'd approach things. New risks come up. And part of risk scanning is keeping an eye out for new types of risk and assessing them and maybe putting them on your risk list and reprioritizing your risk list. Ladies and gentlemen, when it comes to software testing, when it comes to managing the risks in software, we never have the opportunity to do it perfectly. James Bach, the famous author in software quality, talks about satisficing. You work until you're satisfied. It's high enough quality. It's never going to be quite perfect. You're never going to get exhaustive testing, for example, on the projects we're working on. We're never going to have exhaustive risk management. And as a result, and this reflects the fact that we are short of resources. We don't have the time, we don't have the people, and the sort of amount of energy needed to do that. And the space to explore, to test exhaustively, is just prohibitively large. I mean, it's wildly inconceivable that we could test all possible command lines delivered to the Linux command line. I mean, it's a wacko idea. It's just out of the question. So when we're dealing with these situations, it's all about opportunity costs. It's all about taking and triaging. It's about taking our limited amount of time and energy, human resources, and using it to greatest effect. That's what it's about. It's about taking what we have and making as best use of it as we can. And that requires us to be judicious. It requires us to be thoughtful about what we're doing, to test the things that are most worthwhile, to prioritize the risk management on things to which we're most exposed, where risk exposure combines probability and severity if it happens. That's the next question. Didn't know that. Sorry. Risk exposure. Yes, risk exposure is actually at a technical level. It's the product of some estimate of probability and severity if it happens. And this comes up in defect prioritization. We associate with defect reports an estimate of severity and priority. Severity is what's the level of seriousness if it happens. And priority takes into account severity but also probability. So there may be something that's really, really severe, but it has very low probability of occurrence. It's on a really old version of this type of hardware, and it depends on this odd circumstance involving network congestion and disk being almost full or something like that. On the other hand, there can be things that are high priority but low severity. Like the client's name, which is supposed to be featured on the splash screen, is misspelled, and it's something which they care a lot about. It's not very severe. The system is not going to halt because of it. It's not going to freeze. It's not going to crash. But it sure is something the client won't like very much, right? Or it's so hideously ugly to use that people find it distasteful. There's some claims that certain parts of pause sort of behavior are kind of like this. There's some limitations in its aesthetics, and I think we've all been in experience of seeing things like that. So severity and priority are sort of the analog to corresponding notions in the risk management area. Risk exposure kind of corresponds to priority. It considers probability and it considers severity. What are three advantages peer reviews offers when contrasted with or compared to testing?
It's a lot less effort to find bugs.
Good, and that's been shown particularly for inspections, for formal inspections. IBM study showed, an order by several times over. Yeah.
Feedback tends to be a lot quicker.
Good. Feedback is quicker, and particularly feedback involving. We're identifying with peer reviews typically. We're identifying the fault. We're identifying the fault directly rather than just a failure. And with failure, it takes a while. There's a process called debugging, which we need to undergo typically before we find the fault behind the failure. Even if it's an assertion failed, the problem actually may not be there. That's just where it was found. That's where it was caught. When the assertion failed, the actual origin of the problem might lie elsewhere. With peer review, generally we're finding the fault, and in that sense we have quicker turnaround. Yeah, Eric.
You get to avoid future bugs or future similar bugs because everyone learns how the bug is.
Great. Yeah, and arguably that's the most important feature. Peer review is about learning and institutionalizing that learning. So I like that a great deal. How about other things?
Higher quantity of bugs found.
Yeah, so you find more bugs and you find them more quickly and more efficiently. Excellent. Particularly for inspections. What What else? We mentioned earlier, maybe it was the very first question, other than your name. Yeah?
You can hash out like requirements, and so if there's an error with requirements in the code, you're not gonna be able to test it properly, but that's a code review like that.
Good, and I love that. You know, and one of the key things there is that you can't run a requirement and put a test in place for it. Well, okay, I have to be cautious about it. You can have acceptance tests which are based on the requirement, but the statement of the requirement is not something that you can build and run. The statement of the requirement may hold ambiguities. It may hold conflict between the visions of different stakeholders. It may hold a lack of consistency, and you can find those things in peer reviews. Just like you can peer review many types of things we talked about earlier: requirements documents, test plans, design documents, and architectural documents, etc. These are things that we can't directly test. Now, does that mean we should be doing peer review instead of testing? No. In fact, peer review helps testing. It helps understanding the code to understand what needs to be tested. And there's certain types of things which realistically we can't do in peer review. We're not able to sort of think it through so consistently, but we can test it. Random testing, fuzz testing, testing associated with sort of certain types of error conditions that we can't easily reason through in our head, we can do with testing. So it's really about using each to its benefit. Using each in its area of strength is really how to go about QA. It's not replacing one by the other. And it's not just only doing one and not the other. In a situation where testing is difficult, you might put more emphasis on peer review, though. Yeah. Easy-use technique can be used during requirement solicitation meetings, conducted with stakeholders, significantly reduce the risk of misunderstanding. I can list at least 3 such techniques that I mentioned. What are 3? Or what's one of them? Yeah.
Bring more than one person to the
Good.
to the meeting.
Bring more than one person. Stakeholder says something, one of the persons is thinking or writing it down, trying to capture it. They make another statement. That other person may pick it up, where that person writing things down is caught up, making a note of it or trying to understand what was meant, and they miss the later part. So having a second person there is really helpful. How about something else?
Repeating back what they said in your own words.
Repeating back, exactly.
Yeah, not just for the requirements itself, but also for like if you're confused with the wording.
Yeah. That's right, and that really helps if you phrase it in your own words. Maybe sometimes they're using a special term of art. Something to them, it means a very specific thing, and you're thinking it's something generic. This happens quite a lot. It happens when computer scientists deal with non-computer scientists, because we use words in a very specific way. So we'll talk about an exception. And they won't know what's meant by an exception. They may think we're talking in some general way about, colloquially about the using the word exception, and vice versa. There's terms used in very particular fashions in other domains. Another?
What I was gonna say.
Same thing. Okay, good. That's excellent. Another thing you could do would be to ask the stakeholder to repeat something, right? Could you repeat it in different words? That's also helpful. That can help lower the risk of misunderstanding. All those are easy to do. Another thing you can do is, this says during meetings, so a little bit retreat, but if someone's copying these things down, you can show them to the stakeholder at the end and say, look, this is what we thought we heard. Are we off base with any of this? That's another really good technique to use. It does require someone to be kind of a recorder. Okay? Good. Iron triangle, ladies and gentlemen. Iron triangle. Well, this is like a review session. I do these review sessions, before the final exam in my classes, and it goes through kind of many topics, and I'm just talking with my head. But these are like prime exam territory. These are just waiting to be placed on an exam. Okay. You heard it here first. Okay, so iron triangle, ladies and gentlemen. What are the vertices of the iron triangle? Yeah.
Time, cost, and quality.
Good. So time, cost, and people will differ in how they write this. Quality is one way, value is another, scope, and really in some ways value reflects quality and scope, right? You can have more features with decent solid quality, or fewer features with outstanding quality, and still get some value delivered. No, okay, so that's a triangle with those corners. What about it? Why is that of any significance? Yes.
It illustrates that there's often a need for compromise in one aspect to improve on another.
That's right. And the fact is, we live within this triangle our professional lives in many cases. And because of the trade-offs, we have the limited resources and so on, it's often hard to realize fully the stakeholders or clients' sort of expectations or hopes with respect to all three of these areas simultaneously. Achieving the full scope they want might involve taking more time than they'd like, or taking more money than they'd like. I face this all the time. We have stakeholders coming to us, whether it's sort of my entrepreneurial side or here at the U of S, we have people coming to us and they'd like to get something built, but they'd like to get it built for real cheap, and they'd like to build it soon, and they'd like it to be really, really expansive sometimes, and those things are hard to come by. So one thing this relates to is it's hard to get all three, great success along all three at the same time. Now you have to be cautious, and in some previous classes, I actually talked about this because it's not necessarily a linear trade-off amongst these three. For example, in software, time and money often go pretty much together. Why?
Because of the cost of the developers to actually implement.
Yeah, I mean, big costs in software are, not without exception, but generally speaking, the big costs are human costs. Pay developers. Because developers tend to be pretty decently paid, pretty well compensated by societal standards and so on. They're pretty well paid, and so the longer time something takes to deliver, generally speaking, we're going to have more dollars that are required. So there's some collinearity. There's some ways in which those tend to vary. It's not without exception. I mean, there are costs for hardware. There are costs for services we may depend on. If you want to be a gold member of Google Cloud Platform, you pay whatever it is, $300 a month or what have you, and you get that, and that allows you to have all sorts of use of some of their big table infrastructure, et cetera. And so if they're not totally synonymous, but they often go together. Another thing is, ladies and gentlemen, quality. Quality, I'm telling you, quality. And it's more than a buzzword. It's more than just kind of motherhood and apple pie and great great stuff. Ladies and gentlemen, quality is one of these factors that shapes fundamentally the ability of a project to succeed in terms of stakeholder expectations, succeed within the time limit, within the dollar limit, and providing the value the stakeholder wants. It turns out quality is something, if you sacrifice, you're going to have a hard time keeping the ship together. You're going to lose developers. You are going to have the time to delivery often stretch out because you can't stay on top of the bugs, or you're going to have a very disappointed stakeholder because you're not able to match up to their level of satisfaction with the sort of implementation of the requirements. And because the project takes longer, the dollars will take longer. Because it takes longer, they may come with more feature change requests, and it spirals. So it turns out quality is really at the heart of a lot of issues with software dysfunction. And the projects that have good quality often stay good quality. The projects that sacrifice good quality often go to hell in a handbasket, sometimes in 6 months. And I speak from experience. It's a real issue. Like quality ends up having just ramifications in many different areas. So the iron triangle is something we have to work with and grapple with and live within, but it's at the same time, it's something that has some non-obvious trade-offs associated with it. And I will come back in one of the later lectures to discussing these from a systems perspective. Discuss 3 benefits peer reviews bring to a project. So what are some benefits you get from peer reviews? We alluded to them earlier, and I'd be happy if people sort of list those out again. What are some benefits? What do you get out of peer review?
Communication in the team.
Communication within the team. Communication of style. Communication of programming principles. Communication of how parts of the system work. What's another thing you get? What are other things?
New perspectives can catch flaws.
Yeah. Okay. Multiple perspectives can catch flaws in the system and actually broaden people's understanding of the trade-offs or issues within a project. So that's good. Other benefits.
Lifeline problem for you.
Say it again.
Lifeline problem for you.
Yeah, you might find the problems earlier is exactly right. So if you have a peer review that's done before a check-in, for example, maybe before a commit occurs, and there are environments where people require that. People say before you commit, you need to have someone else on the team, at least look this over and give a thumbs up that, yeah, it looks basically good. So that can find issues earlier than if it had just been committed. People you push it, and people do pulls from it, and they find that it doesn't work with their system or whatever, and it spreads that knowledge around. So I like that. Other things, yeah.
You have a more cohesive and effective team in the sense that you're all on the same page.
Yeah, exactly. So it just keeps people in sync more, which is really important. Ladies and gentlemen, in your projects, in decent-sized teams, coordination is the name of the game. Keeping yourselves coordinated. Make sure you stay in sync. Make sure that this latest request from the stakeholder that caused this change in this requirement is known by the other members of the team. You've made a decision about who does integration testing, and now developers are supposed to do more. Who knows about that? You've made a decision about cutting a feature before the next turn-in, so Osgood doesn't find a sort of a bug with the system after the next turn-in. That needs to be communicated. Otherwise, people are going to be spinning their wheels doing work that's not part of that. Coordination, and the problem is that we have these heads which are fairly opaque, and it's hard to make sure that you know what I'm thinking and that I understand what you know. And peer reviews bring people together to sort of share understanding. So they're really valuable in that. And another thing that Eric emphasized earlier is learning. Peer reviews are opportunities to collectively learn. There are opportunities to learn style. There are opportunities to learn how this parts of the system work. There are opportunities to understand how the system originated, because you have people who wrote the predecessor component come to them and they know something about why it does it this way, where it's going potentially. We put in this extra flexibility because, you know, in the next release we have to broaden it to work with multiple platforms or whatever. So ladies and gentlemen, peer reviews are so much more than just, you know, bug finding sessions. They're really important to the life of a team. Define contingency planning and risk mitigation as far as they affect risk management. What are the differences between them? What are the differences between them? Contingency planning and risk mitigation.
One's proactive and one's reactive.
Okay, so to a degree that's true. I like that one. So which one is proactive?
Contingency planning?
Sorry?
Contingency planning?
Okay, yeah, I'll come back to that. To a degree, this is why the statement has some limitations. But I'd actually say, if I had to pick one of those that's proactive, I'd say mitigation, because it's dealing with the issue up front. You're saying up front, look, this is a risk we got to grapple with. And mitigation is putting in place measures, ladies and gentlemen, so that either the risk that you're worried about, it has a lower chance of occurring, or, number two, that if it occurs, it has less serious implications. Okay? So you're putting in place measures that will head off risk exposure, lessen risk exposure. One way to do that is you make it unlikely the risk will come about. The second way, if it comes about, it'll be less severe in its implications. And that's mitigation, is putting that into place up front at the inception, heading off our risk exposure. Contingency planning, how does it differ from that? How does contingency planning differ?
Contingency planning is almost like an after effect of risk mitigation, where if you have something that is likely to fail, even with your safeguards, then you should have a backup plan.
Good. Yeah, so it's all about having a plan in place. And in this sense, it's proactive. There's a proactive element of that. After all, you are investing up front. You're investing up front in clarity of a plan and communicating that, so that people know if this happens, if the build master gets sick, who's going to take over? If someone drops the class, you know, who's the developer, will switch someone from the test team to be half test, half dev, or whatever. If the project manager gets ill, we'll ask, you know, this to happen to handle that situation. So there is some investment up front. So it's not totally reactive, but it really waits until the situation occurs dynamically to undertake the big action, which is typically, you know, enshrined in the plan. So you have in place this plan, and you undertake it to deal with the situation at that point, and that at that point mitigates the issue. It sort of has dealt with it, but you're waiting for the actual risk to materialize rather than just doing it. And these are not just nice concepts. I mean, these are key things. Even having that plan in place means often you can nip the issue in the bud. You can jump on it at the time that it occurs. Okay? This, ladies and gentlemen, was a fair summary of many of the most important concepts that we have covered. I hope that it was helpful. I decided to take the extra time for it, and I'll be sharing this naturally with others. And I hope by so doing, that the quiz will not be merely a evaluative and motivational exercise, but will have marked some learning as well. Okay? That's all for today. Thank you very much, and we will see you on Thursday. That's fine, yeah. Yeah, folks, for today's tutorial, I indicated, I think, group meeting or project meeting in the schedule. It's great if you want to use it for particular subtypes of meetings like inspections, for example. Please be encouraged to do that. If you do that, I would just ask you send mail. Many of the teams have been doing that. It's great. And keep it up. Thank you. Yeah.